And the word a function of, to represent that, we typically use the letter F. So far we read wage is a function of, and then in parentheses over here we put what it's a function of. Well, it's a function of age. So we would put W is a function of, and then in parentheses we place the input variable. So as a function of age. And this alone, if you saw this, you could say the relationship between A, the input, and W, the output, is a function, as a functional relationship. This does not mean multiplication. All this is, it's a notation. It's just like when you say, for example, water. Well, chemists call this H2O. So this doesn't mean H times 2 times O. This is an abbreviation where H represents hydrogen. There are 2 atoms of that, and oxygen. There's 1 atom of that, and so on. Probably said that incorrectly because I'm not a chemist. But anyway, so this is the way we would express that relationship in symbols. To make one final extension is normally, let's say you had an equation. Let's just say that you could determine, came up with a function that you were able to predict somebody's wage, and you were able to find out that to get somebody's wage, you take their age and you add 5 to it and you double the age. Let's just say, so for example, we'd be able to say that someone who is 10 or 20 years old, we could predict how much they're making. So a 20-year-old, according to our equation, again, I just made this up, this isn't a real equation, we would expect that a 20-year-old, well, it's probably bad. Let's just cut out the 2 and just do A plus 5. So we would expect that a 20-year-old would be making $25 an hour. Okay, well, you know, that is just a way of expressing a relationship. So in this case, yeah, every age, every number that we plug in for A, we're only going to get one output, right? It's not like you're going to put in 10, and 10 plus 5 will give you 15, and it'll give you 55. It'll only give you one output, only one wage. So this would be a function. So we could still say wage is a function of your age. Well, obviously, I can only write it one of these 2 ways to express it. I can either write W equals A plus 5 and tell you how to predict somebody's wage based on their age, or I could just tell you that the 2 represent a functional relationship. Well, this is kind of useless, right? I mean, in terms of telling us what to do. So oftentimes we would condense this notation, which is what you've been reading. You could condense this by just writing wage is a function of age. And then on the right-hand side, you could write how to calculate it. So this is the rule. This is function notation. So the advantage of using the condensed form is if I write this, W parentheses 10, that does not mean W times 10, that means how much does a 10-year-old make? Again, remember these are just predictions based on a formula we have. And so we could write W of 10 equals, well, our equation is take the age and add 5 to it. So the age is 10, I'm going to add 5 to it, and that gives me 15 bucks. So according to my equation, the wage as a function of a 10-year-old is $15. This is a convenient way, the condensed form, to talk about functions. Now, one final thing that trips people up oftentimes is, I'm just going to use X and Y here, is when you see something like this. And some people will say, well, that's not a function because, for one, not every output has one input. But keep in mind what the definition of a function is. If this is the input and this is the output, then each number in here can only correspond to one number on this side. Well, so let's pick an input of 2. What's the output for an input of 2? Well, the output for an input of 2, so a 2 over here only maps over to a 6 over here. So that input only has one output.